The first stage is we're going to create a base solution for the model. If we look at the work file, we see that there are a large number of objects in it in the form of series and equations, so it's hard to locate the model object. So the first thing I'm going to do is click on the filter here and take out the series and equation from the display, which makes it easier to find the model, which is labelled here MCI. Now if I double click on that, I open up the model object, and now to create the base solution I'm going to click on, first of all, solve, and then I'm going to set the solution sample to the period that I've chosen. This is actually the current work file sample, but for completeness let's set it here as well. So that's 2014 quarter 1 through to 2021 quarter 4. And if we now click on OK, it will start to solve the model. This can take some time because this is of course a very big model. When the model is finished trying to solve, you'll probably see a message like this: solve terminated, convergence not achieved. In practice the model seems to have converged for all practical purposes, so we're going to continue as if it has converged. Now if we want to actually examine the solutions are stored with this suffix _0. So for example, if we wanted to look at the solution for US GDP, we could type show USY _0. That would show the series for US GDP, and because this is a multi-country model we could also look at other countries' GDP. For example, UKY _0 will give the model solution for UK GDP, and if we press return then we get a spreadsheet with the solutions here. We can of course also look at this graphically, so if we go to view, graph, and then look at multiple graphs, then we see the graphs for the two variables in question here. These, remember, are the model solutions rather than actual data. In the next stage we want to create an alternative scenario in which government spending in the US economy is increased. So to do this, what I'm going to do is first of all clear this graph away, and now I'm going to create an alternative scenario. So to do that I click on scenarios in the model object, go to scenario 1 and then click on overrides, and I can type in any variables which will be overridden when I do the alternative analysis. So in this case it's government purchases of goods and services, so I type in COG as my override variable. Now in order to solve for the alternative scenario, I've got to create an alternative set of data for COG, or government purchases of goods. So to do that I'm going to go to the command line and I'm going to type in series COG _1, because _1 will indicate scenario 1, and then that will be equal to the original spending series COG, plus we're going to increase by 1% of GDP, so that's 0.01 multiplied by US GDP in the base run, so that's USY _0. So we've increased government spending by 1% of the base run of GDP. Now if I now go to solve in the model object, then the active scenario is now the scenario that I want to solve, scenario 1. So I'm going to click on OK here. That will create a new solution with the new GDP series. So clicking on OK here, it starts to run, and of course as we've already seen this will take quite some time given the size of the model that we're working with. Once the solution for scenario 1 is completed, we can look at the results and compare them with the baseline solution. We can do this either using built-in eViews features or directly by using the show command. I'm going to first of all use the show command. So if I type in here show USY _0 and USY _1, that will give me the baseline and the scenario 1 solutions for US GDP respectively. and if I type in USY underscore 1 minus USY underscore 0, that will give me the difference between the two solutions. And then finally, if I type in 100 multiplied by USY underscore 1 divided by USY underscore 0 minus 1, that will give me the percentage difference between the two. If I hit return, that brings up a group object which gives me the results that I'm interested in. I can also look directly at graphical representations of the results. So for example, if I want to look at the percentage effect of on US GDP of an increase in government expenditure, I can type in here plot 100 multiplied by USY underscore 1 divided by USY underscore 0 minus 1, hit return, and that gives me the percentage effect of the fiscal expansion on US GDP. And we can see quite clearly for that that what's happening is we get an initial effect that builds up, reaches a peak after 4 quarters, and then declines down to about a value of just under 1.2 in the long run. Sometimes it's easier to use built-in eViews features rather than looking at the results directly. So within the model object I can produce much the same results as I've done using the show and plot commands by using the following procedures. If I just close down first of all these windows here to create some room in the work file, then I'll go to proc, and then if I want to create a table with the results I can go to make group table here, and the default is to list all the model variables, but in this case that's going to be quite hard to deal with, so I'm just going to list one that I'm interested in. I'm just going to look at USY GDP series, and then I'm going to look at both the scenario 1 and the baseline solution, and also the deviations of the actual from the scenario 1, and finally the percentage difference. So this will produce much the same results as we did using the show command. If I now click on OK, then it produces a table for me with the results that I'm interested in. This gives me the scenario 1 solution for US GDP, the baseline solution for US GDP, the difference between the two, and the percentage difference between the two. We can also use built-in eViews features to look at the results graphically. So if I shut down this window and then go to proc, make graph, again I'm going to concentrate on the US GDP series, so I'm going to click on US, listed variables, and then list USY as the one variable I'm interested in. And then in this case I'm just going to look at a graph of the percentage deviation of the active scenario, scenario 1, from the baseline solution. Click on OK, and it gives me essentially the same graph that I obtained using the plot command earlier.